Right, today we're going to talk about section 9.1, which is talking about solving trig equations with identities. I'm going to break this up into three different sections. The first part, I'm going to just do the identities. Then the second part we're going to do verifying identities. And then finally, the last part will be solving equations with identities. So first, let's look at our identities. Now, all of these identities are on the formula sheet that I gave you. So I want you to look at that and make sure you can recognize where these identities are. Now, the first ones that we're going to discuss are the reciprocal identities. Now the reciprocal identities, we already know these. The first one is, we know that the cosecant of x is equal to the reciprocal of the sine of x. We know that the secant of x is 1 over the cosine of x. And we know that the cotangent of x is equal to 1 over the tangent of x. Also, if we take the reciprocals of both sides of the equation, on this one I get that the sine of x is equal to the reciprocal of the cosine of x. The cosine of x is the reciprocal of the secant of x. And the tangent of x is equal to the reciprocal of the cotangent of x. So those are our reciprocal identities. The next set of identities that we're going to be dealing with are the quotient identities. And the quotient identities are simply that the tangent of x is equal to the sine of x over the cosine of x. We also know that the cotangent of x would be the reciprocal of that, so it would be the cosine of x over the sine of x. So those are our quotient identities. The next one is the Pythagorean identities. And we already know the first one, and it is sine squared of x plus cosine squared of x is equal to 1. And so looking at, we know that this is the sine of x, this is the cosine of x. We're looking at our unit circle, and this is the angle x. Opposite over hypotenuse, adjacent over hypotenuse. And we know according to the Pythagorean theorem that a squared plus b squared is equal to c squared. So therefore, sine squared of x plus cosine squared of x is equal to 1 squared, which is 1. And so that gives us our first Pythagorean identity. Now, let's take this Pythagorean identity and we're going to divide everything by, or divide both sides of the equation by cosine squared of x. Which, go ahead and split it up in this first section. And so notice that this is sine of x over cosine of x. Well, sine of x over cosine of x is tangent of x. So this would be tangent squared of x. And then here, cosine squared of x over cosine squared of x would give me 1, because they cancel. And then 1 over cosine squared of x, if I look up here, 1 over cosine of x is secant of x. So this would be secant squared of x. And so that gives us our second Pythagorean identity, which is tangent squared of x plus 1 is equal to secant squared of x. So that's our second Pythagorean identity. Now let's do the same thing that we did before. Let's take the original identity, sine squared of x plus cosine squared of x equals 1. And let's divide both sides of the equation by sine squared of x. So here, sine squared of x over sine squared of x is equal to 1. Cosine of x over sine of x, if we look up here, that's equal to the cotangent of x. So this would be cotangent squared of x. And then 1 over the sine of x is equal to the cosecant of x. And so this would be equal to cosecant squared of x. And so that gives us our third Pythagorean identity, 1 plus cotangent squared of x is equal to cosecant squared of x. So those are 3 Pythagorean identities. And then the last identities that we're going to look at are our even and odd identities. So in this one, first of all, let's remember we were talking about even and odd when we did the graphing. So remember, our 2 even functions that we dealt with were the cosine of x and the secant of x. So if I have the cosine of negative x, remember that is the same as the cosine of x, because the cosine function looks like this. So it doesn't matter whether I take a positive x or if I take a negative x, I'm going to still have the same y value. And so cosine of negative x is equal to the cosine of x. And then remember, because it's a reciprocal function, the secant is also going to be an even function, and so it's just going to be equal to the secant of x. So we'll talk about that a little bit more. Then let's look at the odd functions. All the rest of them we said were odd functions. And so if I have the sine of negative x, that's going to be equal to the negative of the sine of x. And again, if I remember my sine function and what it looks like this and keeps going here and keeps going here. So if I have an x value here, notice my y is positive, but if I go to negative x, then my y value would be the same value but would be negative. And so if you go negative in the x, your y will also be negative. And so it's an odd function. Same with the tangent of negative x. If I look at the tangent of negative x, and the tangent function look like this, so for this value of x, I have a positive y, and then if I go to negative x, same x over, but in the negative direction, notice that I'll have the same y, but it would be negative. So this would be negative tangent of x. And then the reciprocal functions will also be odd, and so cosecant of negative x will equal negative cosecant of x, and cotangent of negative x will equal negative cotangent of x. So these are all of the identities that we will be using in this section, and they're all on your formula sheet, and I'm going to go ahead and stop the video now, and I will do the next part on verifying identities, so that if you have questions, you don't have to listen to a whole video again. You can just go to the part that you don't understand. But this is just kind of the first explanation of what the identities are.